Hello guys, so after we have learnt a bit of heat and temperature, it is time for us to learn about the effects of heat on any substance like solid, liquid or gas. So we will be identifying a important topic and try to understand that with its normal behavior and also the exceptions, right? फिजिक्स में भी एक्सेप्शंस होते हैं, उसमें भी थोड़ा सा केमिस्ट्री का हाथ रहता है कभी कभी. सो वी आर गोइंग टू स्टडी अबाउट थर्मल एक्सपेंशन. व्हाट हैपेंस व्हेन वी हीट ए सॉलिड? व्हेन वी हीट ए सॉलिड the molecules go further apart, right? When we heat a solid, the molecule goes further apart. When the molecule goes further apart, that means it is going to expand. The solid is going to expand because the molecules are going apart, the intermolecular space is increasing, so the solid is expanding. So normally substances, what happens? Normally substances expand on heating. So this is the normal phenomena. It expands on heating, and this phenomena in a whole is called thermal expansion. This phenomena is called thermal expansion. This thermal expansion, when it happens for a body, it happens from all direction. There can be change in length of the body, there can be change in area of the body, there will also be change in volume of the body. So there can be, this expansion can happen via change in length, change in area. This can also happen via change in volume. ठीक है? So it can happen change in length, change in area and change in volume. And whenever we talk about this, there are different names associated with it. So if there is a change in length, that kind of expansion is called linear expansion. Actually, see, whenever a body expands, it doesn't only expand linearly. So if I say whenever there is a change in length, it is called linear expansion, this is a wrong thing that I am propagating right now. So what exactly it means? It means that when a body, suppose there is a body like this, okay? So if the length changes, that is the after heating the length becomes like this, suppose, okay? So this is what becomes the extended length. So this amount of length change, this phenomena is called linear expansion. The length का जितना change हुआ उसको हम linear expansion बोलेंगे. अभी देखो length का change हुआ तो area का भी तो change हुआ है ना. So ये जो area का change है इसको हम लोग क्या बोलेंगे? हम इसको बोलेंगे सुपरफिशियल एक्सपेंशन. ठीक है, सुपरफिशियल एक्सपेंशन. नाउ नेक्स्ट थिंग इज definitely only length is changing, breadth is changing, not only happening that, the height is also changing. I have not shown, but definitely on heating the height may have gone up to here, right? So there has been some height change also, right? So this height change along with length and breadth will cause change in volume. When this total is considered, then it will be considered as cubical expansion. So when we will say about total change in volume, when we will explain the change in volume due to increase in temperature, the change in volume में कितना change हुआ किसके लिए? Temperature increase होने के लिए, then I will call it cubical expansion. If I talk about only about the area part, then I will talk about superficial expansion. भाई एरिया चेंज हुआ, क्या चेंज हुआ, क्या हुआ इसमें? एरिया चेंज हुआ, इसका मतलब सुपरफिशियल एक्सपेंशन हुआ. अगर सिर्फ लेंथ का चेंज का बात करें तो सिर्फ लेंथ का चेंज का बात करें तो जब हम बात कर रहे हैं इसका मतलब ये नहीं है कि सिर्फ लेंथ का ही चेंज हो रहा है, चेंज तो सब कुछ का हो रहा है, लेकिन हम बात सिर्फ लेंथ का कर रहे हैं। तो हम बात अगर सिर्फ लेंथ का कर रहे हैं इसका मतलब हम लीनियर एक्सपेंशन का बात कर रहे हैं। अगर एरिया का करेंगे तो वो होता है आपका सुपरफिशियल एक्सपेंशन, एंड इफ यू आर टॉकिंग अबाउट द टोटल वॉल्यूम इट इज कॉल्ड क्यूबिकल एक्सपेंशन। ठीक है, सो सी whenever there is a change in length, so if somebody asks me by giving an iron rod that what will be the change in length, then how will I calculate? So this change in length, suppose this is the final length L1 and this is the initial length, so this is related like this 1 plus delta t into alpha. ठीक है ना, this alpha value is specific, this alpha value is specific for a substance. ठीक है ना, it depends on what? It depends on material. Substance means material. Material. ठीक है ना, specific for a material. So this is listed like this. Alpha value for iron is like this. It is listed. Steel के लिए इतना है, iron के लिए इतना है, mild steel के लिए इतना है, copper के लिए इतना है, ऐसे ऐसे listed है. So I'll use that value and then find out what is the change in length. If it is said find out the change in area, then this will be like this: A1 is equal to A0 1 plus, this is termed as beta delta t. Delta t is what? This delta t. What does delta t means? I have already explained in the last video. Delta t means change in temperature. Whatever the temperature has risen, change in temperature. The temperature rise will be called as delta t. Clear? This is beta delta t and this one is V1 is equal to V0 1 plus gamma delta t. ठीक है, now what is this alpha, beta, gamma? These are basically coefficients and nothing else. This alpha is called, please write down, this alpha is called coefficient, C-O-F-F-I, coefficient. This alpha is called coefficient of linear expansion. This beta is called coefficient of superficial expansion. This gamma is called coefficient of cubical expansion. Clear है? Linear expansion, superficial expansion, cubical expansion. So basically normally क्या होता है? If you increase temperature, things will expand, right? Volume will go high. But this is what normal is. Okay. I hope you have completed this. Completed? Okay. देखो अभी. Now this is normal, but I'll write down some substance like silver iodide, water and silica. Silica, when you talk about less than 80 degrees Celsius, or water from 0 degree Celsius to 4 degree Celsius, or AGI I think 80 to 140, yeah 80 to 141, ठीक है. So when we are talking about this three substance, now in this temperature range this three substance basically contracts on heating. ठीक है, so normally क्या होता है 80 से 140 you are heating it, और 80 से 90 you are heating it. Which one? AGI, it should expand. Unfortunately they don't expand. So there are reasons to it, complicated reasons, intrinsic reasons, not required at this level. इसका मतलब ये नहीं है कि not required है, इस लेवल में जरूरत नहीं है आपको मैक्सिमम जानना है वाटर के बारे में. दिस विल बी आवर पॉइंट ऑफ स्टडी. ठीक है, वाटर के बारे में. नाउ इन केस ऑफ वाटर फ्रॉम 0 डिग्री सेल्सियस टू 4 डिग्री सेल्सियस व्हाट हैपेंस? इट contracts, it doesn't expand, remember. So from 0 degree Celsius, if you see at 0 degree Celsius to 4 degree Celsius, water, what happens? Water, we are talking about water contracts. ठीक है ना, water contracts, and you know that ice is lighter than water. This is known to you. It floats on water. Shouldn't be, right? A solid should not be lighter than its liquid form, correct? but in ice it is a different thing altogether. So normally what happens, it should expand, it is contracting. The reason why this anomalosity takes place is hydrogen bond. There is a very special kind of bond that takes place in water, which is called hydrogen bond, which you will study in detail in later part of your career. But at this moment you can know all these things. This hydrogen bond is a special type of bond that happens in water molecules, and when water forms ice, that is cooled from 4 degrees Celsius to 0 degrees Celsius, these hydrogen bonds try to form a cage like structure with lot of vacant spaces inside it. Whenever you have vacant spaces inside it, your volume goes up but your mass remains the same, and hence the density decreases. And that is why, due to this hydrogen bond and formation of cage like structure inside ice, due to what? Hydrogen bond, formation of cage like structure in ice, ice floats in water. Okay? At 4 degrees Celsius, water assumes the highest density. At 4 degrees Celsius, water assumes the highest density. Why? ठीक है ना, water assumes the highest density at 4 degrees Celsius. Other than that, well, at 0 degrees Celsius, when it forms ice, it is lighter than water. ठीक है ना. So whenever we talk about any water amount, then if you operate at a temperature range of 0 degree to 4 degrees Celsius, the 4 degrees Celsius temperature water will stay at the bottom. This is the basic fundamental you need to know. And at 4 degrees Celsius, it has the highest density. Don't forget it. 4 degrees Celsius highest density. 0 degree से 4 degree तक आपका जो होना चाहिए उससे उल्टा होगा, और 4 डिग्री क्रॉस करके चला जाएगा, इसका मतलब जो होना चाहिए वही होगा. ठीक है. तो 4 डिग्री के बाद it expands, 0 to 4 degree it contracts. Normally 4 degrees Celsius to 0 degrees Celsius, this is what? Cooling. A substance should do what? Contract or expand. What do you think? 4 degrees Celsius to 0 degrees Celsius, a substance should contract or expand. It should contract, right? It should contract. But unfortunately or fortunately, actually fortunately, because this is what helps us live in this world, you will understand a few minutes after this. Okay, so for 4 degrees Celsius to 0 degrees Celsius, it should contract, but water expands. This phenomena of expansion of water while you cool it from 4 degrees Celsius to 0 degrees Celsius is called thermal anomalous expansion. So this is what anomalous expansion of water is. When water is cooled from 4 degrees Celsius to 0 degrees Celsius, it expands, and this is called anomalous expansion. ठीक है? This is anomalous expansion. And at 4 degrees Celsius, water has highest density. Let us discuss two important graphs over here. Density versus temperature. Of water. So we'll start with 0 degrees Celsius and we'll end our study at 10 degrees Celsius. ठीक है ना? So this is 0. This, let us take this as 4 degrees Celsius. This, I'll take this as 10 degrees Celsius. And let us take this density as 1 gram per centimeter cube. ठीक है? So from 0 degrees Celsius to 4 degrees Celsius, it is heating. In heating, normally what should happen? It should expand or contract? It should expand. Expansion means increase in volume. So density should have decreased. But here everything is ulta. So density definitely have increased. So density will increase like this. Up to 4 degrees Celsius, the density will increase like this. Okay? After that, it falls. After that, it is normal. Okay? Because on heating, density decreases, that we know. But वाटर का तो 0 से 4 तक जो भी होगा उल्टा होगा, तो डेंसिटी क्या होगा आपका बढ़ेगा। हो गया। अभी सेम ग्राफ अगर आपको वॉल्यूम के साथ बनाने दे दिया तो क्या करोगे? सेम ग्राफ दे विल गिव विथ वॉल्यूम। Volume of 1 gram water, and here is the temperature 0 degree Celsius, 4 degree Celsius, 10 degree Celsius. So, see, normally at 4 degree Celsius the highest density of water is lying there. What is the highest density of water? At 4 degree Celsius density of water is 1 gram per centimeter cube. Okay? So, let us mark 1 centimeter cube, because volume of 1 gram of water will be 1 centimeter cube, right? Volume of 1 gram of water will be 1 centimeter cube at 4 degree Celsius. So, this is the part. So, this is plotted. Next is, if we start from 0 degree Celsius, definitely at 0 degree Celsius the volume will be less or more, that you need to find out. So, you are basically heating. So, if you are heating, the volume should normally increase, but water के केस में उल्टा होगा, तो डिक्रीज होना चाहिए। तो इसका मतलब ये तो ऊपर से आ रहा था ऐसा, है ना। उसके बाद 4 डिग्री से 10 डिग्री वॉल्यूम क्या होना चाहिए? बढ़ना चाहिए, तो बढ़ेगा ऐसा। हो गया वॉल्यूम। तो दिस यू हैव टू मार्क 1 centimeter cube. Yeah, and this way you will show, so that teacher doesn't get confused and he understands your answer directly. Okay, clear? So that is all about anomalous expansion of water. Now we will do a very important consequence of anomalous expansion of water. So how does aquatic fish or marine life survive in very cold countries, very cold weather, -2, -3 degrees Celsius, and here is a pond, a lot of fishes inside it. How will it survive? It should form ice. So what happens first? This is ambient. Ambient means atmosphere, nothing else. So number 1, let us take T ambient, temperature of ambient as say -3 degrees Celsius. So number 2, what will happen? This water inside it, this is still in water state, that is liquid state. So let's take this as T water, as say 10 degrees Celsius. So if this part has higher temperature than ambient, then heat will flow from water to ambient or pond to ambient. So heat flows from pond to ambient, है ना। First of all, this surface temperature will come down. Definitely surface का temperature कम होता रहेगा. So this surface temperature reaches 4 degrees Celsius, suppose. As soon as it reaches 4 degrees Celsius, this is highest density, right? This is highest density water. As soon as it reaches 4 degrees Celsius, water at 4 degrees Celsius will sink, right? Water at 4 degrees Celsius will sink. So 4 degrees Celsius will come here, right? And you know very well that from 0 degrees Celsius to 4 degrees Celsius, density increases. So whenever it reaches 4 degrees Celsius, it has come down, isn't it? It has come down, and it will form a gradient. Gradient means like this kind of thing. At one layer it is 4 degrees Celsius at the top above layer. So after that some of the water will reach say 3 degrees Celsius. It will just occupy the above portion of 4 degrees Celsius, right? Just the top portion of 4 degrees Celsius. Here it is 2 degrees Celsius. Here it is 1 degree Celsius. here it is 0 degree Celsius. This kind of gradient will form. Please write down, a temperature gradient will form inside the pond. A temperature gradient will form inside the pond in which 4 degree Celsius will be at the bottom and 0 degree Celsius will be at the top, with a ice layer on it, right. Here there will be ice layer, full stop. After that you write next point. Next point is, the ice layer prevents any further heat loss from pond to ambient. Ice layer prevents any further heat loss from pond to ambient. ठीक है ना, ice is a very bad conductor, so it will not allow any further heat loss from pond to ambient. ठीक है, so that is how this gradient is maintained. So this water remains water, it doesn't become ice, and the fishes live. Okay, we let them live, and so they can live only due to anomalous expansion of water. If there was no anomalous expansion, believe me, you will not get any fish in the winter time. Hopes did a very good experiment on it. So this was the Hopes apparatus, that which I am drawing right now. So there is water filled up in this apparatus. Here there is here there is ice, one tray of ice surrounds this total cylinder, okay, like this. Here there is a thermometer, you can draw a thermometer like this. Here there is another thermometer, you can draw a thermometer like this. This is T2. Okay, so first of all, before let's take this temperature as 15 degrees Celsius. Total water is at 15 degrees Celsius. उसके बाद आपने ice tray रख दिया. You just keep this ice tray. So what will happen? This part will first reach 4 degrees Celsius. When it reaches 4 degrees Celsius, this 4 degrees Celsius comes down. Right? This 4 degrees Celsius comes down. And it remains as 4 degrees Celsius. This temperature doesn't come down any further. Why? Because as soon as this temperature reaches 4 degrees Celsius, this 4 degrees Celsius has a highest density, it cannot go up, right? If it cannot go up, it cannot get any further heat loss. It will not lose any further heat, right? It cannot go up anymore, that's it. Next, this part, what happens? This becomes 0 degrees Celsius. लूजेस हीट में तो मिनिमम टेम्परेचर कितना हो सकता है 0 डिग्री सेल्सियस. और 4 डिग्री है और 0 डिग्री है, मैक्सिमम 4 डिग्री है, जो नीचे पड़ा हुआ है तो ऊपर में मिनिमम 0 आ सकता है. तो 0 किधर जाएगा? 0 आ जाएगा इधर, यहाँ पे 0 डिग्री सेल्सियस, यहाँ पे 4 डिग्री सेल्सियस. दिस इज द होप्स एक्सपेरिमेंट, वेरी वेल नोन एक्सपेरिमेंट दिस वन. ठीक है ना, वेरी वेल नोन एक्सपेरिमेंट विथ 2 ग्राफ्स which is associated with it. First of all is T1. So this one, so see, if you say this T1, this starts from 15 degrees Celsius, right? It starts from 15 degrees Celsius and it reaches 0 degrees Celsius like this with time, right? With time. If you just plot the same thing as T2 and here it is a time, then what happens? Then it doesn't reach 0 degrees Celsius, okay? It doesn't reach 0, it will reach up to 4 degrees Celsius. That's it. It will reach up to 4 degrees Celsius. But does this reach this way? No. The slope is different because see, normally what will happen, this up to this, and after that what will happen? If you increase the time, it will go like this. So this is the curve over here. ओके, दिस इज फॉर T2 द बॉटम वन एंड द अपर वन इट जस्ट कम्स डाउन, ठीक है ना। तो एकदम सिंपल है। दिस इज ऑल अबाउट द हीट पार्ट वन दैट आई वांटेड टू प्रोपागेट टू यू। आई होप यू हैव अंडरस्टूड, एंड after this we will be having our next lesson on certain things about heat sources and thermodynamics. Okay, so we'll skip the part that which we have to remember. We are not going to go into those things. We are going to go into conceptual things, and after this lecture there will be always a CPS waiting for you inside the app, ठीक है ना। ऐप में आपके पास CPS आ जाएगा, क्लास प्रैक्टिस शीट। You have to practice that, and we'll discuss in our live session coming week, Wednesday 9:30, whatever you wish. Okay, 9:30 we'll discuss it, what time we should have that live session, as we have had last week. Nice one. So that will be via our live classes app only, ठीक है ना। We'll be having our through live classes that is inbuilt inside the app. Okay guys, I hope you enjoyed the session. Thank you. Good night.